Okay, earlier I was trying to look up online how to make big objects in a 3D printer. For example, a BFP 3000. Not the, the $20,000 3D printers. Those are easy. The problem with these ones is they're cheaper, and they're cheaper for a reason. But I'm totally happy with it. Anyway, when you try to make large objects out of ABS, which is, this plastic here, it starts warping. And it does that because, it'll print out a layer, and that layer will cool before the next layer comes on. So you always have a colder layer below and then a warmer layer on top. So the warmer layer is contracting because it's going to cool. So it'll contract more than the layer below it. So you'll get this effect where it's sort of like a string on a bow. You've got your bow part here, and then the layer above that's shrinking and pulling in, and it like curls the piece up. Not that much. I'm exaggerating with my hands, but that's the problem. And I was looking up ways to get around that. I couldn't find anything online, so I'm explaining it here. I'm making this big piece here, actually, which happens to be a lot bigger than the recommended size for this ABS plastic. The size limit is supposed to be like 10 centimeters before you start getting major warping problems. But this is obviously significantly bigger than that. I should turn this thing around so I can see if I'm actually in the camera. Okay. And this actually has another piece up here, which is also much bigger than the bed of the machine, so it won't even fit in there. So the first thing I did, this is kind of the easy part, was I made it like puzzle pieces. And to get it to fit snug, I got this on the first guess, but it was really just a guess. I took 1/10 of a millimeter off the whole surface here. Everything that was touching this has 1/10 of a millimeter, shaved off. And that fits quite snugly. Very well. Now, to make these individual pieces, first I said, okay, let me just print one out and see how it turns out. And that's what this is. And as you can see, it's, less than ideal. Because it was doing that thing I was talking about where, it just starts peeling up. And the problem is it starts mashing against the nozzle because it's peeling up and pressing against the nozzle, and it gets all out of shape, and it's a horrible mess. Oh, but check out the internal structure. I love how it, you can pick honeycombs, you can pick different internal structures for the spaces inside, or you can just do it all solid, but that wastes a lot of plastic. But anyway, I stopped this before it was anywhere near finished because it was clearly making a mess. So next I said, okay, maybe if in those layers, as I start going up in the layers, I break them up into sections. So put these holes in, and that way, if I use the bow and a string analogy, it would be like cutting the string, so it wouldn't be pulling up nearly as much. And that helped a huge amount, actually, but it's still peeled up from the bed a little, and you can hear it when it's peeling up from the bed. It'll make this sound, and then you'll look and see that, oh, there's a space under there because it's peeling up. But that was a major improvement. And then I did another one, and with these I've already cut off the bottom. This is like what they call the raft, and that's like the first layer they put down to kind of help it stick down. And normally you do two different materials, the raft one material and this and the other material, but I just do it all in the same material and cut it off because that's what I feel like doing. So on this one, I did a couple things. One, down at the bottom, I made these 1 centimeter cuts into the object that are only one plastic layer thick. So just enough to break up the stresses after the raft before I get to the object, so that I can start the object with no stresses on it. And then I made this bottom part only 2 millimeters thick before I get to a hole. So that's 4 layers of plastic, and that's not enough to really start bending it up. And then it's just got lots of holes, and the holes go, almost right up to the end on both sides. Because on the second try, I didn't get the holes. I didn't put the holes that close to the ends, and the ends started blowing up. So get as close to the ends as possible. And oh yeah, and the other thing I did, there was one other thing. I took the, come on, focus. I raised the starting point of the bed by 1/4 millimeter. So that way the nozzle at the beginning was closer to the bed and kind of mashing the plastic right into the bed so it sticks harder, so that it would be harder to peel up. And I don't know if all three of those things were necessary, but it worked, so whatever. Yeah, it seems to be doing very well. And it is harder to peel this off at the end, but you know, the piece comes out perfect. As you can see here, it's totally flat on the thing. Once you figure out the little intricacies of these machines, you can do some really amazing things. I figured I better start printing out some bigger robots so that I could, you know, study the mechanism more closely and stuff. Okay, I really just like playing with big ones.